Okay, let's cover adding and subtracting fractions. We first need to start and look at when the denominators are the same, when the bottoms are the same. So let's first think about money. If we had 2 quarters minus 1 quarter, write down what that would be. Think about money, 2 quarters minus 1 quarter. Well, that's 1 quarter, isn't it? So that's kind of funny because this number on the bottom just stayed 4, but we went 2 minus 1 and we got this one up here, and that's correct. So why didn't we do this? 2 minus 1 over 4 minus 4 to get 1 over 0. That's nonsense, isn't it? That is nonsense. And the strange thing about fractions is that when these bottoms here are the same, we just leave them alone and we just combine the tops. Let's have a look at inches. 7/8 of an inch subtract 1/8 of an inch. Write down the answer. So if a piece of wood is 7/8 long and you want to plane off, cut off 1/8 of an inch, what are you going to be left with? Write it down, and remember the pause button's down here, bottom left corner. That would be 7 minus 1 over 8, wouldn't it? 6/8. And we can put that in lowest terms. Divide the top by 2, divide the bottom by 2, and we get 3 quarters, right? So again, when the bottoms are the same, we can combine the tops. And that's the strange thing about fractions when you're adding and subtracting them. Let's have a look at baking. 1/3 of a cup of sugar plus 2/3 of a cup of sugar. What's that going to be? 1/3 of a cup of flour plus 2/3 of a cup of flour. 3/3, isn't it? And we can put that in lowest terms. Divide the top by 3, divide the bottom by 3, and we get 1 over 1, which is 1, or 3 over 3 is 1. In any case, it's 1 cup of flour. So, again, when the bottoms are the same, we combine the tops. That's how we add and subtract fractions. So, obviously, you do this then. If you had 2 dimes plus 3 dimes, think about money, what would that be? 5 dimes, right? Put in lowest terms. 5 to 5 goes once, 5 to 10 goes twice, and that's a half of a dollar. So this is all it's just like a thing we do in algebra called adding like terms. Let's have a look at that. Adding like terms. Here's how adding like terms works. If you have 2 apples and you add 3 apples, how many apples is that? 5 apples, isn't it? Just like the dimes. 4 dimes plus 4 dimes would be 8 dimes. So it's like terms. Or 5 bananas, 5b plus 3b would be 8b, 8 bananas. So that's how we add and subtract fractions when the denominators are the same. Okay, adding and subtracting fractions when the denominators are different. We're going to look at examples where we need to factor one denominator. That's one bottom of a fraction. Let's take an example with money. 1/2 of a dollar subtract 3 dimes, 3/10, right? What do you think that is? Write down the answer. Well, here's the procedure. We factorize one of the bottoms, in this case 10, and 10 is 2 times 5. Now, this is 2 times 5. In the previous session we saw that we need to make the denominators the same if we are to add or subtract fractions. So to make this the same as this, we've got to multiply this by 5 over 5. And now our half becomes 5 over 5 times 1 is 5, 5 times 2 is 10. It becomes 5/10. So the interesting thing is this half of a dollar has now been changed to 5 dimes. Which would you prefer, half of a dollar or 5 dimes? Well, they're both the same quantity, and that's okay. We can multiply the top and bottom of a fraction anytime we like. It does not change the quantity of the fraction. But it does help us because now we have 5/10 minus 3/10, which is 2/10, right? And the lowest common denominator, what do you think that is? In ATER, or the LCD, is 10 in this case. Let's have a look at an example with inches. 3/8 of an inch subtract 1/4 of an inch. So the procedure is, well, you can recognize that 4 goes into 8. And if we factorize 8, we get 2 times 4. Now, if we want to subtract fractions, the denominators need to be the same. So, 2 times 4. How do we change this bottom to be the same as this? Well, we multiply it by something. What do we multiply it by? Multiply it by 2. So, multiply this by 2 over 2. And now we've got, this becomes 1 times 2 is 2. 4 times 2 is 8. So, the 1/4 becomes 2/8. 1/4 of an inch is the same as 2/8, right? So 3/8 minus 2/8 is 1/8, and that's how that works. We could look at, go ahead and do this one then. 1/2 of a tablespoon of nutmeg plus 1/8 of a tablespoon of nutmeg. Go ahead and do the procedure and add those together. Well, you need to make the bottoms the same. 8 is 4 times 2. So change this also to 4 times 2. But you must multiply the top by 4 also. So the half of a tablespoon becomes 4/8, which is the same quantity. It just looks different. And the denominator is the same as this denominator. So we got 4/8 plus 1/8, which gives us 5/8, right? So go ahead and do this one then. 5/27 minus 1/9. You'll see that 9 goes into 27. And 27, of course, is 9 times 3. So I factor 27 to get 9 times 3. Now make this bottom the same as this bottom. Make the bottoms the same. Make the denominators the same. Multiply that by 3 over 3, right? So we have 5 over 27 minus 3 over 27. And if the bottoms are the same, we can subtract the tops. 5 minus 3, 2. 2 over 27, right? Now, the reason we use this skill here, before we go on, looking at this example, the lowest common denominator is 8, right? Looking at this example, the lowest common denominator of the two fractions is 27. So just to make a note of that. And let's see why we use this this technique here, multiplying by 3 over 3, because you've learned a different technique before algebra, which is to find the lowest common denominator and put the fractions like this, minus 1/9, get the lowest common denominator, that type of thing. Why do we do this? Well, because it helps later on when we work with letters. For example, 1 over x squared plus 3 over x. When we factorize x squared, we actually get x times x. Okay, so to add these fractions, we need to make the bottoms the same. So if I multiply that by x, now the bottoms are the same. But I also must multiply the top by x. So x over x, just like 3 over 3, right? So I have 1 over x squared plus 3x over x squared, which is 1 plus 3x over x squared. So you'll see this later. But the point is, this is a good skill to use, and you need to do this in your homework, because we've got to learn how to do this technique with numbers so we can then apply it to letters. Give you another quick example. 1 over AB minus 7 over AB. Whoops. make that a C. Okay, 1 over AB minus 7 over ABC. Make the bottoms the same. Multiply this by C over C. So you've got ABC, ABC, and C times 1 is C, so that's C minus 7 all over ABC. So you'll see that later. Okay, let's look at adding and subtracting fractions when we have different denominators again, but this time we need to factor both denominators. So one example in a way is 1/2 plus 1/3. What is that? Common mistake is to do things like this. People like to say, okay, that's 1 plus 1 over 2 plus 3, which makes 2/5. Or does it? Let's check that common error, for example. 1/2 of a square would look like this. Add 1/3 of a square would look like this. Here's the area of 1/3 of a square. Right? First of all, does that look like 2/5 to you, or does it look like more than 2/5? Because 2/5 is, let's think about that. And here's a nice little trick. Watch this. The problem with adding 1/2 and 1/3 is that the bottoms are certainly not the same. And if you look at this shape, the shape of 1/2 an area of a square and the shape of 1/3 of an area of a square, they're completely different size shapes. So they're very hard to add, and there's different size shapes until we do this. Split this also into thirds and split this one in half. Now, how many rectangles or squares of equal size do we have? We have 1, 2, 3, 4, 5, 6. And how many are shaded? 1, 2, 3. So this area now is in fact 3/6. If you look at this area, we've got 1, 2, 3, 4, 5, 6 squares, and they're all supposed to be the same size. And 2 of them are shaded. So the shaded area is in fact 2/6, isn't it? So 1/2 and 1/3 is the same as 3/6 plus 2/6, which is 5/6. And, you know, that would look like this. 1, 2, 3, 4, 5, 6. And how do we do it? By algebra. That's what we're here to learn. By math, basically. We make the bottoms the same again. Multiply this by 2, and then multiply this by 3. Now we have 6 on the bottom. But don't forget, you've got to multiply that by 2 over 2. Multiply this by 3 over 3. 3 times 1 is 3. 3 times 2 is 6. So this is 3/6. 1 times 2 is 2. 3 times 2 is 6. That's 2/6. So if we had, for example, 2/3 minus 1/4, we can't subtract right away because these bottoms are not the same. We need to make the bottoms the same. So what do we put here and here to make the bottoms the same? You write it in. See if you can do it. 3 here and a 4 here, right? Now the bottoms are the same. 4 times 3, 4 times 3. But don't forget, multiply the top by 3 here and multiply the top by 4. So this 2/3 becomes 4 times 2, 8/12. Now 2/3 is the same as 8/12. 1/4 becomes 1 times 3, 3. 4 times 3, 12. 1/4 becomes 3/12. The same quantity, it looks different, but it's good because the bottoms are the same. 12, 12. 8 minus 3 is 5, so that's 5/12. Okay? How about, oh, and just before we go, lowest common denominator here, of course, is 6. Lowest common denominator for here is 12. That's the lowest common denominator of both fractions. Let's have a look at mixed numbers. 3 and 1/8 minus 1 and 2/3. First of all, we'll go ahead and change them to improper fractions. 8 times 3 plus 1 over 8. So 3 and 1/8, that's 24/8 plus 1/8, that's 25/8. Minus 3 times 1 plus 2 over 3. Because 1 and 2/3 is 3/3 and 2/3, which is 5/3. So we've got eighths and thirds. If we want to subtract fractions, the bottoms have to be the same. So put something here and put something here so that these bottoms are the same. Put an 8 here and a 3 here. So multiply it by 3 over 3 and this by 8 over 8. So this becomes 75 over 24 minus 40 over 24. Which is 35 over 24. And as a mixed number, 24 into that goes once, and remainder, write it down, 11, so that's 1 and 11 24ths. Okay, now another thing that can happen is that you might need to factor both of the bottoms. So let's have a look at 1/6 plus 5/8. Now in this case, 2 goes into both bottoms, you'll see. If we factor both of the bottoms, 6 can be factored to be 2 times 3. 8 can be factored to 2 times 4. Now try and make the bottoms the same, because if you add fractions, the denominators need to be the same. So put something here and put something here to make the bottoms the same. So we do the least amount of work to make the bottoms the same. If you put a 4 here, now over here we're including this 2 and this 4. Okay? Now what would you put here so that both bottoms are completely the same? Would you put a 3? Right? So you got 2 times 4 times 3, 2 times 4 times 3, same bottom. Multiply this top by 4 though, of course, and multiply this top by 3. And now we've got 4 over 8 times 3, 4 24ths. So 1/6 became 4 24ths. 5/8 became 5 times 3, 15. And that's 24. And of course the lowest common denominator here is 24. 4 plus 15 is 19. So 19 24ths. Right? How about 9/10 minus 8 35ths? Factorize the bottoms and then make the bottoms the same. So 10 can be factored to 5 times 2. 35 can be factored to 5 times 7. Now put a number here and put a number here so that both bottoms are the same. So let's see. Over here we've got a 5. Same 5 here and here. But we don't have the 7. So put the 7 there. Now I've got the 5 and the 7. 5 and 7. So what do we need over here so that both bottoms are the same? Need a 2, right? So multiply this one by 7 over 7 and this fraction by 2 over 2. And 7 times 9, this is 63 over, multiply these, that's 35 times 2, 70, minus 2 times 8, 16 over 35 times 2, 70, right? And then go 63 minus 16. And we should get 47 over 70. Okay, so really quickly, I mean, if you had a mixed number, that's not a big deal either. I mean, something like 3 1/9 minus 5/6. What you want to do, again, when you're subtracting fractions, is to turn these into improper fractions. That is sometimes helps. So 9 times 3, 27 plus 1, that's 28/9 minus 5/6. Now factorize the bottoms. 9 is 3 times 3, 6 is 3 times 2. Now make the bottoms the same. Put a factor here and a factor here to make the bottoms the same. Now this is a 3 and another 3. So if we put a 2, now we've got the 3 and the 2. from here, right? So to make the bonds completely the same, we need to put the other 3 over here. So multiply that by 2 over 2 and this by 3 over 3. And go ahead and solve. Let's see, 2 times that would be 56 over 6 times 3, which is 18, minus 15 over 18, which gives us 41 over 18, and 18 into that goes 2 times, remainder 5, I think, so 2 and 5 18, so check that. Now, why is this procedure, why do we do this multiplied by 3 over 3 and 2 over 2? Well, again, if we had something like 3 over AB minus 5 over BC, which you'll see later on in algebra, first step is to make the bonds the same. So multiply this by A, multiply this by C, and now you have BCA, BCA, same thing. So multiply this by C over C, and this by A over A. Excuse me. So you got 3C minus 5A all over ABC. So that's why we use this method. And in this case, the lowest common denominator of both fractions is ABC. Of course, for this example, your lowest common denominator was 18, right?